Hello friends, so today the question is given a circle and a number of chords C, in how many ways can we draw these chords making sure that no two chords intersect. So just see as an example, if the number of chords are 1, the points will be 2. So if we have 2 points on a circle A and B, in how many ways can we draw a chord? There's only one way. So the answer becomes 1. Now let's see if number of chords are 2. So the number of points will be 4. Then in how many ways can we draw the chords so that no two chords intersect? So let me draw the circle. So we have A, B, C and D. So let's fix our point A, and if we have two, now remaining points are 3. Let's see what happens if we draw a chord from A to B. Now the remaining points are 2, and we know from remaining 2 points there is only one possible solution. Now let's see. If we draw a chord from A to C, that will result in intersecting chords, right? So we cannot draw it. Now let's see if we draw a chord from A to D. That's pretty much possible. So remaining are 2 points only, and we know for 2 points only one solution is possible. So in total our answer becomes 2. So I hope now the question is clear. Now let's see how we can solve it with dynamic programming. So even before going into the solution, let's see how we can use brute force to solve this problem. Keep in mind guys, if we can solve a problem with brute force, then applying memorization is relatively easy. So let's see how we can solve it with brute force. Even before we start with that, let's see what happens if we have chords 3 and points 6. So we have 6 points. A, B, C, D, E and F. Alright. Now I'll fix my first point to A. Now I have to draw chords. So how many remaining points are there? 5. So in all possibilities I can only have 5 points I can draw from A. So now let's see, can I draw a chord from A to B? If I draw a chord from A to B, how many remaining points are there? 4, right? So 4 is actually 2 chords, and we have already solved for 2 chords. There the answer is 2. So let me quickly draw these solutions. So from A to B, if we draw from A to B, then we have two possibilities, right? And the other one is from C to D and F to E. So if I draw from A to B, then the total number of possibilities are 2. Now let's see if I can draw from A to C. Can I draw a chord from A to C? So if you see, if we draw a chord from A to C, basically we are partitioning our space into two parts. Remaining part on the left side or the upper side is 1, and number of points on the other side is 3. So we can clearly say if the remaining part is an odd number, then it definitely means that there will be some intersection. So we cannot have any solution, and we cannot draw a chord from A to C. Now let's see if we can draw from A to D. If we draw from A to D, the number of chords in upper partition is 2. Sorry, number of points in upper partition is 2, and on the remaining on the down in the lower partition is also 2. So we know if we have only 2 points, then the solution is 1. So I'll quickly join it. Okay. Now quickly we can decide whether we can join A and E. If we join A and E, on left there is 1, on right there is 3, so there will be intersection. So no, we cannot join A and E. What about A and F? Can we join A and F? If we join A and F, on the left side or on the first partition we have 0, and towards the other partition we have 4. So yes, we can join it, and we know that if there are 4 remaining points, then there are 2 possibilities. So B can be joined with C and E can be joined with D. And what's the other one? B can be joined with E, C can be joined with D. So this is our brute force approach, and the solution we have got is 3. So if we have understood till here, I think we can safely write our solution. Let's see how we can write our solution. So I will name the function as recurse, rec only. Integer points. So let's think about our base cases. So if points is 2, then the answer is 1. If points is an odd number, then we have 0 solution. Till now we know this only, right? So let's see. So now we are going to fix one point and combine with all other points. So let's see, if we have a circle and we have 6 points, A, B, C, D, E, F, and now we are trying to draw chords from point A. So how many chords are possible to draw from point A? That is 5. That is 1 minus number of points. So I can safely say I is equal to 1, I less than points, I plus plus. So this will iterate from 1, 2, 3, 4, 5. 5 times. Okay. And now, while it's iterating till 5 times, what is the partitions that we are getting? So the first partition would be, if I is 1, that means that we have joined it with the first partition. So remaining is I minus 1. So I'll say int left points is equal to I minus 1. So if we join A and B, how many points are there in the left? 0. And how many points are there in the right? That is points minus I. So we have 6 minus 2, that is 6, just wait 1 second. So we have points are 6 minus 1, that is 5, and again minus 1. So that will be points minus I minus 1. Let's see. So if we are drawing from A to C, how many there are on left? 1. So I is 2, 2 minus 1 is 1. So left points is right, and right there are 3. So 6 minus 2 minus 1, 6 minus 3, that is 3. So this is correct. Now how will we recurse? So we should return let's have a integer ways is equal to 0. So ways plus equal to recurse left points multiplied by recurse right points. And finally we return ways, right? But there is a problem in this solution. So let's say if we have 4 points. So if points is 4, let's quickly try run and see what is the remaining issue with our solution. So points is 4. 4 is not equal to 2. 4 is not odd. So we traverse from 1 till 3, right? 1, 2 and 3. So left point is 0 and right point is 4 minus 1 minus 1, that is 2. So that will means that we are recursing with the value 0 and then we are recursing with value 2, which is as good as we joined A and B. On the left side there are 0 points and on the right side there are 2 points. So what we are doing is recursion 0 multiplied by recursion 2. Now we have missed one base case, that is 0. If the point says 0, what should our function return? So if points is 0, then we should not return 0. In fact, we should return 1. Why? Because there is a multiplied sign. So anything multiplied by 0 becomes 0, but that is not the case for us. We are actually then going to rely on the other thing, right? Okay. So this is our normal brute force solution. Now, how can we apply dynamic programming to this? So we can easily use something called as memoization, where we store the answer in a map and then we can directly see if we already have calculated that solution. Since this is an overlapping problem where we are going to calculate again and again for the points that we have already found, so we can use memoization where in a hash map we can store our results that we have already calculated. So let me write the main solution for us. So solution actual input was chords and we were solving for our return recurs 2 into chords, because for one chord there are 2 points. This was our complete brute force solution. So now let's quickly transform into DP using my memoization. So we need a hash map. So hash map now we can directly add our base cases in this map. Hash dot put, what is our base case? 2 is 1, then for 2 points the solution is 1, for 0 points the solution is 1. Suppose that we don't need these two values. Okay. In fact, what we can write is if hash dot get points is not equal to null, then return hash dot get points, right? And the only thing that is left is storing our result. Hash dot put points and the answer is ways. So that's it. We have converted a simple recursive solution to DP solution with memoization. Thanks for watching. See you next time. One small correction here is that we need to pass the hash as well. Hash map integer hash. So this will also be hash comma hash.